This proof is called the separator. It's dealing with overlapping triangles. It's called the separator though because our game plan is going to be to separate the triangles out, then try to prove what we want to prove. Okay, so write in your given information first. And go ahead and mark it on your picture. So I know y. These two angles, and I also know that xy is congruent to zy. All right, so that's the given. In an overlapping triangle situation, we're going to separate them out, but what triangles are we going to separate out? It's helpful to notice YWV is what our given is, but what we want to prove is YXV. I'm going to mark where that angle is with a dot, and I'm going to mark YZW with a dot, because it's something I want to prove also. So the triangles that I want to separate involve those two angles. So I'm going to mark this one in red. And I'm going to actually draw it out here. V, X, Y. This angle is incorporated with the triangle I'm going to mark in blue. And I'm going to draw it off to the side in blue. It's Y, Z, W. Keep in mind, these are the angles that I'm wanting to prove. Now, if I want to say these two angles are congruent, what am I probably going to have to say before that? The triangles are congruent. So make it our first goal to show that the triangles are congruent. And boy, I don't have very much information. But we can mark something. We know XY is congruent to ZY. And those are incorporated in my triangles. So XY, ZY, XY, ZY are congruent. I can mark that. Do you see anything else that I could have? When you undo them, it's not as obvious to see, but they have a common angle. What angle is it?
Y.
They both share angle Y. So what property can I use? Say reflexive.
Reflexive.
Good job. So reflexive property is going to allow me to say that angle Y is congruent to angle Y. Angle Y congruent to angle Y. Can I say that the triangles are congruent yet? Say no.
No.
Good decision. Oh man, it'd be really great if I could get this side to be congruent to this side.
Really?
Is it?
Yes.
Are they?
Yes.
Probably.
Okay.
Because we will last one.
Maybe ask it this way. What piece of given information have we not even used yet?
We've used angle YWV is congruent to YVW.
Yeah, these big angles I haven't really used yet. So let's take a look at the big triangle again. What kind of triangle is it? Isosceles. So if it's an isosceles triangle, I could say that this whole side is congruent to this whole side. And here's why that helps me. So whole side is congruent to whole side. In other words, YW is congruent to YV. Oh, that helps. YW is congruent to YV. So I use the big picture to kind of find it, but really I'm just using the fact that it's isosceles triangle. So I'm going to write isosceles triangle theorem. Converse of isosceles theorem, because I went from angles to the sides. Vy congruent to Wy. Now, do I have enough to say the triangles are congruent?
Yes.
What's the postulate?
Hypotenuse leg.
Not hypotenuse leg, because that's only right triangles. This one I'm
Side
going
angle side.
throw back to side angle side.
My favorite. Sounds postulate.
Let's see.
Yes.
Let's make sure on our order. I'm going to go 1 dash 2 dash, so XYV. And do 1 dash 2 dash ZYW. We already kind of discussed, once I have the triangles congruent, I can say these purple angles are congruent. That's what I want to say. So, by C, P, C, C, I'm going to say exactly what I want to say. YXV is congruent to Y. C, W. Separator.